fourth ring, that gives you an idea of how far away they are from the center. Okay, so this is kind of like, it's almost like Beijing. So you basically have these rings, so like first ring, second ring, third ring, and so on. That tells you how far away you are from the center. And then of course you have the angles. So, the first point, 2 comma pi over 4. Now remember, every point is going to start with an R and then the theta. Okay, so the 2 means we're going to go to the second ring. Okay, so like the second ring road. And then the pi over 4 is obviously this angle right here. So again, we go second ring, 1, 2, and then pi over 4 is obviously right there. Okay? Now if I wanted to, I could figure out the angle first and then decide how far to go out. I mean, there's nothing wrong with that. Like here, for example, if I really wanted to, I could have gone up 3 units and then to the right by 2 units, and that certainly still get the same point. So whether you want to think about the R or theta first is up to you, but generally speaking, we just write them in this order. Okay, point B. So we'll label this with A. Point B is 4. Now that's my R, the radius, or the distance from the center. 2 pi over 3 is my angle. Okay, so this time let me look at the angle first. So 2 pi over 3. Does everybody remember the 1, 6, 2, 6, 3, 6, 4, 6? Remember that? So that's an angle of 2 pi over 3. And then the R is going to be 1, 2, 3, 4. And there's point B. Easy, right? Whoa, this next one has a negative R. What are we possibly going to do about that? Well, first let's look at the angle. 3 pi over 2. Well, you know this is an angle of 0. Pi over 2. Pi. 3 pi over 2 is straight down. Okay, like going south. But instead of going 3 units forward, what do you think we're going to do? We're just going to go backwards. Okay, which 1, 2, 3 looks like right here. And that is point C. So notice, if I really wanted to, I could have just said that the angle was pi over 2. And then I could have said that R was what? 3. It turns out we have 2 different ways of representing the same point C. And that's only the 2 points that I just wrote. As a matter of fact, this angle, if you consider all real numbers for the angle, that means you could basically have angles bigger than 2 pi, right? So you could basically represent the angle by going all the way around the circle plus pi over 2, plus 2 pi, plus 2 pi, plus 2 pi. So how many different ways do you think I could actually represent point C? Right, there's actually an infinite number. Okay? Now, is the same true about rectangular coordinates? Like right now, this point is 2 comma 3. Can I write that any other way? No. So this is one very big difference between rectangular coordinates and polar coordinates. Rectangular coordinates, it's kind of like a one-to-one function. Remember what that is? Okay, so basically like every element here only has one element here, every element here only has one element here. Okay, well that's not really the case here. Okay, so every single one of these points can be written with an infinite number of ways for coordinates. Anyway, point D. Okay, so notice this time we have a negative angle. Well, that's no problem. We know how to deal with negative angles. For positive angles, we turn counterclockwise, right? So for negative angles, we just turn clockwise. So notice this would be like negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. Okay, and the R is positive, so I do go forward exactly 1 unit, which is like the first ring, and that is point D. Now, by the way, do you think it's possible to write D with a positive angle? Sure. As a matter of fact, If you